Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Aiman bin Muhammad Yusof, and we are from Group 2. Okay, first of all, I will introduce our group members. First is me, Muhammad Arif Aiman bin Muhammad Yusof, my teammate Sheikh Zainul Shafiq, and also Gausinia. Okay, I will introduce about the introduction. Okay, for the introduction, recycling is the process of turning waste material into new material and things. Recycling reduces energy consumption, air pollution, and water pollution. There are two ISO standards that have to do with recycling, which is ISO 15270 2008 for plastic waste and ISO 14001 established in 2015 for environmental management control of recycling process. Convolutional neural network is a type of a deep neural network used in deep learning to analyze visual imagery, such as image and video recognition, image classification, and image segmentation. CNN are regularized multi-layer perceptron variations. Multi-layer perceptron network are frequently totally linked network. Okay.
Good day, Doctor. I'm Gausinia. So I'm going to present about the methodology. So first is the CNN, the most used neutral system method for solving image layout problems. So one of the advantage of this is that fewer constants dramatically increase the time it takes to learn while reducing the amount of data required to create the module. Okay, and then we'll move to this VGG16. So this is the Oxford-based visual geometry group created the VGG module. So this is the module. So this module consists of 3 by 3 filters with a strain and a pair of size 1 and also map pooling size of 2 with a strain of 2 of all of them. Next is the ResNet. So this ResNet, furthermore, the layer corresponds the picture that is imputed using a sequence of filters with 3 times 3 window sides. With the use of the loss function, probability, or softmax function, more complicated and detailed characteristics are recovered as the training process through the layers. So this is the flow chart. So first we start and then we load the data from the prepared data set. So there are two things going on. First is the testing samples. Alright, so testing samples, and then another one is the training the sample. So training the sample, it has like two things going on again and again. So one is the convolutional layer and one is the max pooling layer until it reach the both reach at the CNN based feature learning network. After that, we have the training sample feature and then image classification and then also output classification results at the end. So that's all from me. Thank you. So we use the Google Colab to do the task one. So the first one is step one. We connect the Google Drive to this Google Colab, and then for the step two, we feed data set directory. So the goal to do this step is to pass the data set from the step 2 into Colab so that it can access to the Google Drive folder. And then step 3 is to create train and also the validation data directory. So in this case, this step is actually necessary because we want to use the path directly from the train and also the validation feature folder. So for the CAN client is 156, the path is 310, CAN one line is 77, and also the path one line is around 133. And then we do construct the next one is we does this. Okay, so this is important because we want to construct the CNN program. So this program will have the tensor flow. So the next one is we construct the CNN module. So for the CNN module, we developed this that includes a layer, output, shape, parameter of the CNN module. And also it is also noticeable that the result is total primes is 1903477, which is equal to the trainable primes, and also non-trainable primes is 0. And then the fifth step is pre-process the input data. So for this pre-process input data, in this we rescaled all photos by 1 point over 255, and then it also consists a 3-method flow where the picture is taken from the target directory and resize it to 150 times 150. So as a result, in class mode, it will build a data bench and label of the identity photo. So there are 446 photos in all divided into two categories. So there will be 210 photo identified in total of the two categories. So the label's batch shape is 20 and the data batch shape is 20, 150, 150, and 3. And then the next one is the step 6, start training process. So here I include the epoch of 15 because the larger the epoch, the better the accuracy will show. So in this, the best accuracy that I got is, I think 94%. And then the lowest one is 0.0023, which one equals to 23% here. And then for the step 7, we plot the outcome. So for the outcome, this is the graph that we got in. So in this graph, it also shows the highest frequency, which is 94.29%. Okay, and the highest training accuracy is 1, and the validation is the percent of 94.29%. So this is the explanation about the task 1. Thank you. Next, I'm going to explain about another task 1 that we will add our own picture of the cannon and also about the bottle. So again, like just now, first we connect to the Google Drive, and then we feed the dataset directory. And then here, when we create the train and validation directory, I add extra new canpad here and also print new canpad length. So for the result, it shows like the can train length is 156, pad train length is 310, can 1 length is 27, pad 1 length is 133, and also the new can pad length is 3. And then we import the transfer flow, and then we create the step 4, construct the CNN module. So here, when we construct the CNN module, it's the same like the task 1, same params as well. And then when we pre-process the input data, it's also the same like the task 1. And then we start training the process. I still use the 15 epoch. And then here, I think the highest I get is around um, 0.9381. And then the frequency is, the loss is around 0.018. 0.018. Right? And then next, we plot the outcome. So this is the outcome for the training average accuracy and also the loss. And then we feed sample image to observe which is paired and cat is dominant. So the first one is the paired and can stay at the same distance from the camera screen. And here is the picture. And then next one is the can stay and the pad move further backward. So it does this. It does show the right one. And then the last one is the pad stay and the can move forward backward. Further backward. And then it shows the same thing. Whereas the bottle is at the front and the can is at the back. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zainal Shafiq bin Said Zaifuddin. Today I will like to talk about task 2, which is VGG and ResNet. Okay, I will talk about first is VGG. As you can see, this is step 1. Is we put the coding that collab with Google Drive. For the step 2 is a feed data set directory. All the data will be on the Google Drive. As you can see here, Google Drive we set as a collect network and under recycle. And step 3 is create train and validation data directory, which is to create the folder inside the Google Drive. Step 4 is a construct pre-trained model with VGG. It will construct pre-model with VGG. As a result, it will generate the result consists layer output, shape, and parameter for model VGG. And step 5 is it is a pre-process for in the input data that rescale or image 1 over 255, which using a 3 method flow, which is a resize 150 times 150. Okay, for the step 6 is a start training process. As you can see here is a step pre-epoch. We put 10. Our epoch also 10, and validation step also 10. So to select accuracy, I refer it here. As you can see here, like this one, the one that I blank using a blue blank. So I pick the 99 since it's the highest one. So as you can see, validation accuracy is 0.99 and loss is 0.0012. So the accuracy here is, which is we times 100 and we will get 99%. But here, the result accuracy show us that it means like 100%. So for the step 7, plot the outcome. So as you can see, we using a coding that plot the graph. So plot the graph epoch versus training validation accuracy. As you can see, here is the highest dot for the previous data, which mean I mean is from the step 6. So the highest one is, as you can see, is 99%. So here is got a 99%. So let's go to the ResNet. Same as before for step 1 until step 5, but the different coding will start at step 6. So as you can see here, the training process validation accuracy is still the same to calculate for the percentage. And step 7 is plot the outcome. This is the result from the data. That's all for me. Thank you.
Okay, for now, I will discuss about the conclusion. Okay, CNN has an excellent capacity sequence data analysis such as natural language processing. There are two basic operations in CNN, which is convolution and pooling. The convolution operation using multiple filter is able to extract features from a dataset through which their corresponding spatial information can be preserved. The pooling operation is also called as subsampling, and the operation is used to reduce the dimensional of the feature maps from the convolution operations. Okay, here is the recommendation. For this project, I would like to recommend the performance of recyclable material classification system should be improved. The second recommendation is images that have been used in this task must be clearer images to get the better or best result. The last recommendation is making improvement in Google Colab in order to have a better results within the short time. Okay, thank you. That is all from us.